Yeah, good morning. We'll start with the lesson today. In our last class, we are discussing on a sliding window protocol, a reliable transmission, how a reliable transmission will be done from the host to the host at the data link layer level, how frames will be transferred or retransmission of the frames will be done based on acknowledgement and on timeouts. In that, first we had discussed about the stop and wait protocol. Then we have gone with what is the disadvantage of that stop and wait protocol. Then we have gone with one bit single sliding protocol. So one bit single sliding protocol, we have discussed 0 and 1 will be there. So based on that, it's going to maintain the sequence number, and it will solve the cases of C and D, that is where acknowledgement will fail and where timeout will occur, duplicate packets will be there. So this is the things which we had discussed, and later on we gone for why only means only one frame at a time we will be sent from one system to the another system, means the link capacity will be wasted. So the bandwidth of the link capacity will be wasted. Why can't the more frames can be sent? That question arises later on. For that, what actually the sender will do, sender will send 1 2 3 as a 4 as a frames, and once it gets the acknowledgement of 1 2 3 4 frames, then it will additively increases. As I told in a last class, 5 it will become 6, it will become 7, it will become, so finally when the capacity fill ups again, it will come back to the cycle. So like that we had discussed, and we will go in depth into that sliding window protocol, how a sender and a receiver will maintain a different variables, buffer will be maintained to acknowledge the send frames, and how send frames will be maintained in a sender side as well as a receiver side. Today we are going to see further. Now coming from the last class link, I will share the screen again here. Just a minute. Yeah. Now in the last class, as I told you, that we are on this particular thing, that a sender will send more than one frame at a time to maintain the link capacity. So there what happens, 1 2 3 assume in a figure, as the sender will send, the receiver has to send an acknowledgement for 1 2 3, and sender once again it will send 4. So if 4 acknowledgements will come correctly, again it will send 5. Like that, the things will be keep on moving. Now assume if errors is there in between, we must discuss in a real-time cases, not like that theoretical cases that all frames will go correctly and all acknowledgements will come correctly. No, not like that. In a real time, maybe assume that one acknowledgement will come, second frame will fail there, discard means frame will be discarded, third acknowledgement will come. If second acknowledgement not came, what the sender has to do in between frame is not there. So because of this particular things, many things will arise. Due to that, a different variables will be maintained in a sender side, as I told you in a last class. The first important variable it will be maintained for a frame is a sequence number. If once the unique sequence number will be there for a frame, so automatically identification will be very easy, as like the USN in a university. In a university, lakhs together students will be there to identify a particular student. The USN plays a very much important role. So USN will tell which batch, something like that. So the particular student can be identified easily. Like this, a sequence number will help to identify a particular frame. Coming to the next thing, the other important variables are sending window size. So what is the sending window size? For example, now at present 3 is going, assume window size is 3, additively next it will become 4, means SWS will become 4, 5, 6, like that it will keep on increasing. So to maintain what is the size of that particular window, so we are going to use SWS at a sender side. Now, the other two important variables you observe there, the last acknowledgement received. That means the last, as I told in the last class, that last acknowledgement received will be there. Last frame sent will be there here. Now, for example, I have told you that assume that 1, 2, 3 frames will go to the receiver, and the acknowledgement has to come from the receiver side. Assume that the one acknowledgement will come and the second acknowledgement will not come, means the frame has been discarded, and a third acknowledgement will come. Now, what is the problem here? You have to analyze clearly the last acknowledgement received, what will be there. Now, at that particular stage, the 3 will, when 3 comes, the 3 will be the acknowledgement number. The last frame sent is 3. Then what happens? It will go for 4, 5, 6. Now, actually to say that either the receiver should not send the acknowledgement of an 3, right? Why? Because 2 has been discarded here. 2's acknowledgement has not sent. So either that should not be sent here. Otherwise, the expected negative acknowledgement, something like that. Identification of that 2 has to be done from the receiver side to the sender. Otherwise, sender never comes to know that. This is very much disadvantage which you have to observe here. Why other protocols will come. I told very clearly. For example, in the last class, what I told, 1, 2, 3 frames are going. Assume that third frame is discarded. If third frame is discarded here, 1 and 2 acknowledgement will come. Means last acknowledgement received is 2, last frame sent is 3. But it will wait for a time to get third acknowledgement. But third acknowledgement doesn't come because the third frame is discarded on the receiver side. So what happens here? Now, again, identification means the difference is there here. The last frame sent is 3 and the last acknowledgement received is 2. So because of that, what it will do, 3 will be returned. That is good here. Means that problem will be solved here. But which problem is not solved here? The in-between frames, if it files there, how to identify that? This keep in your mind. I will give you the solution for this in a coming next time. Now observe here, at a sender side, sender also maintains the following variant. Always this is a formula that the last frame sent and the last acknowledgement received, means last frame sent LFS minus LAR should be always less than or equal to the window size. This is the rules. So if window size is like that, LAR will be at the leftmost and the rightmost, the LFS will be there. Means last frame has been sent from this side will be taken into consideration, and LAR, the last acknowledgement, has been received to the first going frames like this. Now coming to the next thing. When an acknowledgement arrives, now you see what I told, it will be there. The sender moves LAR to the right. There may allowing the sender to transmit another frame. For example, 1, 2, 3 frames has gone. Now, acknowledgement for 1 comes, next expected is 2. Second acknowledgement is expected. The last acknowledgement received is 1. So, it will be there at 1. So, once one acknowledgement comes, means receives, then it will. Also, the sender associates a timer with each frame it transmits. Timer is must. If acknowledgement not comes within a time, it will consider it as a timeout. That always a sender will have a buffer to maintain SWS frames. This is very much important. You have to keep in your mind. Always, I will tell like this: a window will be maintained, 4 frames, 5 frames, 6 frames, like that. Where it will be maintained? As you must think like a network designers or a computer professionalist. In a computer, you need some space to maintain, correct? So that is nothing but maybe it's a cache memory, or in a processor only you can take some memory, or you can use your RAM, it's left to you. But a buffer of a memory should be maintained to increase. Once the buffer gets filled, then automatically a circle will be done. So like this, the Windows size will be maintained from an sender side. Now come to the receiver side. Receiver side is also same. Yesterday I give an example to you. That is, I am having a 2 ants. I will throw through balls. The other person, whoever is there, he must have a capacity to catch the 2 balls at a time. Correct. He will also have a 2 ants. He will catch at a time. Correct. So, for example, assume I will throw 3 balls at a time. I will expect him to catch the third ball also. No, it's not possible. Why? Because I will tell, sir, he is having, or you will tell, sir, he is having only 2 hands. Third ball he can't catch. If you throw 3 balls at a time, it's impossible. Like that, whatever SWS is there, for that, the same thing should be there as an RWS. The upper bound on the number of out of order frames that the receiver is willing to accept. That means how much capacity is there of that particular RWS to receive. Based on that capacity, the capacity will be intimated to the sender. See, my capacity may be like that. I will tell one real-time example. I'm going to use an Intel 7 processor system. My friend is using P4 system, and we both are chatting. Now P4 system is slow, we know that, and Intel 7 is 8th generation system is very fast here. Maybe here the buffer size is buffer and memory size, processor size is very fast in the high 7 systems rather than a P4. Now P4 will intimate in beginning itself my buffer capacity is only this much, and you have to send according to that. So this is very much important here, that is RWS. Now largest acceptable frame, this is the sequence number of the largest acceptable frame. This is very much important, that I told you, no, largest acceptable frame. For example, 1 2 3, largest acceptable frame, my size is window size is only 3, that is I can accept 3. If I tell 3, 1 2 3 will be sent from the sender. Means if largest acceptable frame is 3, for example, assume here the largest acceptable frames are 7, means RWS is 7 in a size, so it will tell 7. So 1 2 3 7 will be sent from a sender. So based on this particular variable LAF, that is largest acceptable frame, means it is expecting you send me 3 frames, I can bearable for that. So this is an important variable which will play the role. Last frame received means which frame it has been received and how much still capacity is there to receive. So these both variables will tell that particular concept. Coming to the next slide. Yeah. Receiver also maintains the following invariant, that is, you can see LAF, that is last acceptable frame minus LFR should be always less than or equal to the window size as usual, correct? No, why? Because the LAF last acceptable frame, for example, assume that 7 it will tell. So here last frame it has been sent, assume 3 like that. So 7 minus 3, 4. Still 4 can be taken into the consideration. So window size, always it should be less than or equal to the RWS. Coming to the next things. Now, when a frame with a sequence number, sequence num arrives, what does the receiver do? This is very much important. You must be carefully, you listen this particular sequence. If sequence number is less than or equal to LFR, what do you mean by this? LFR means sequence number, LFR means last frame received, or sequence number is greater than the last frame, the last acceptable frame, discard it. Very simple. Now we'll take one example, I'll tell you. 1 2 3, assume that the last acceptable frame means receiver will have is 3, means maximum 3 frames, means LAF will be 3. The last frame received means which frame it will be sent, which frame it will be received. Assume the last frame which has been received, if it is less than or equal to that particular frame. For example, assume the frame which has been sent is a 4 it will send. 4 will not be taken into consideration. Why 4 will not be taken? Capacity is 3 only. 1 2 3 has to come first. Later on 4. Why here LAF will vary? Are you getting? Now assume that 1 2 3 has been there already. 1 2 3 are sent from the sender side, and next here LAF is correct. 3 it has been told already. The frame received is 1. 1 received means here LAF will go to 4. Correct. So here 2 received means LAF will go to 5. Like that, it will be going this side, it will be coming right side, and this will move that side. LAF will move that side. Now assume once it is going like this, if sequence number is less than of that already received frame, If it is less than, assume that the second frame already received. Again, second frame will come. Assume sequence number is a second. Now we don't take that. It will discard that particular thing. Coming to the next thing, if LFR is less than, assume if LFR, that is last frame received, is less than the sequence number, and sequence number is less than or equal to the acceptable frame, then accept it. That means it will falls in between. 100% it will falls in between. That is, one is already received, second came, assume third is the capacity, second it can receive. Why? Because 3 means 2 is less than or equal to 3, correct, and here 1 is less than 2, correct. So accept it. How the receiver needs to decide whether or not to send an acknowledgement. Now here, after receiving that, accepting that particular frame, either acknowledgement should send or not, it will decide on the correction of that particular frame, as we have already discussed. Now coming to next, let sequence number to acknowledgement. Now how acknowledgement will be sent? Denote the largest sequence number not yet acknowledged, such that all frames with a sequence number less than or equal to the sequence number to acknowledgement have been received. Now very simple here, which sequence number is there and which one is acknowledged. For example, received is second frame received, whether second frame is acknowledged or not. Sequence number to acknowledge means which one to be acknowledged. It will keep on telling. First, based on the last received frame, LRF, based on that, once the frame has been received, it will be checked out, detected with an error, something, it will be done. So for that, the acknowledgement should be done. Either the acknowledgement should be sent or not, it will be noted in sequence num to ACK, that variable. The receiver acknowledges the receipt of the sequence number to ACK even if I numbered packets have been received. So whatever number of a packet, sequence number of a packet it's received, for that it will give the acknowledgement number and it will send back that to the sender. The receiver then sets, after sending an acknowledgement, observe carefully, after sending an acknowledgement, how it will be sent? LFR is equal to sequence number to the acknowledgement and adjust set. So which frame it has been received, means last frame received, it will send that. Now how the LAF will be set? Whatever a window size, assume window size is 4 and received, last frame received is 2. So what happens here? 2 plus 4, 6. That means up to 6th frame, it can send from 2 to 6. Again 4 frames. Like that, it will be LAF will be test. Means that is the 6th frame, up to 6th frame, the maximum 6th frame you can send. The intimation will be given to the sender. Now, we'll come with an example where you can understand clearly. For example, suppose LFR is equal to 5 and RWS is equal to 4. What do you mean by LFR is equal to 5? That is, last frame received is 5th frame it has been received. Assume window size is 4 now. Now observe carefully. What will be the LAF? LAF will be 9 usually. 5 plus 4 is 9. The last acknowledgement that received sends was sequence number 5. If frames 7 and 8 will arrive, that is up to 9th frame it can come. LAF means at a receiver side. Now assume 7th and 8th frames will arrive, they will be buffered because they are within the receiver window size. Yes, it is within the window size. That is, it's not less, the sequence number is not less than or equal to LFR, and it's not greater than or equal to LAF. In the previous slide we have seen. So the 7 and 8 will be accepted. Now assume the sequence here very carefully, but no acknowledgement will be sent since frame 6 is yet to arrive. Frame 6 not came. Here last frame received is 5. I told you in beginning, if second frame discarded, then how third acknowledgement will come. Now observe carefully here. This sentence plays very much important role. But no acknowledgement will be sent since frame 6 is yet to arrive. It never sends acknowledgement until the expected frames will come until 9. Now you see here, that is frames 7 and 8 are out of order. That means just it will store in a buffer, and acknowledgements will not be sent to the 7 and 8. Now assume the sequence. Frame 6 arrives. Now frame 6, it's late because it was lost first time and had to be retransmitted. Maybe it may last first time, retransmission should be done. The timer of that will time out in a sender side, it will retransmit the 6. Otherwise, due to congestion, it arrives late. Now receiver acknowledges frame 8 and bumps LFR to 8 and LAF to 12. Observe, very much important. This is very much important, again carefully. Now what happens here? Now 6, 7, 8 has been taken into the consideration. Now receiver acknowledges frame 8, not 6, 7, 8. The last frame will be acknowledged. That's it. The last frame will be acknowledged. Once it will acknowledge, automatically LFR will become 8. Now whatever a 5 is there, automatically it will become 8. And 8 plus 4, the LAF will become 12. So this is one very important concept you must know. Now coming to here, we'll dig out some disadvantages in this sliding window protocol and how to solve based on this we will discuss now. When timeout occurs, the amount of data in a transmit decreases. Since the sender is unable to advance its windows. This is very important. When timeout occurs, the amount of data in transmit decreases. Whatever timeout is there, if timeout occurs, the data what it has to be sent automatically decreases. When the packet loss occurs, this is important. When a packet loss occurs, this scheme is no longer keeping the pipe full. That means once the frames, whatever packets is there, it will discard. The longer it takes to notice that a packet loss has occurred, the more severe the problem becomes. So how much time it will take to recognize that the particular frame or a packet is missing. So based on that, the criticalness will be there. How to improve this? There are different methods. Observe here, the first method is negative acknowledgement, NAK, piggyback method. We can tell like that also. Additional acknowledgement, selective sliding window protocol, that is selective acknowledgement. So these three methods will be used to improve still the sliding window protocol performances. Coming to the improvement of this sliding window protocols and further, how to improve this, how a negative acknowledgement will work, you must see here. Now, negative acknowledgement, that NAK, how a negative acknowledgement will be sent from a receiver to the sender. Receiver sends NAK, negative acknowledgement, for frame 6 when frame 7 arrive. In a previous example, I told that frame 7 and 8 will come, 6 will not come. So receiver will not send an acknowledgement for frame 8 until 6 arrives. So no acknowledgements will be sent. It will keep on in a, assume that the timeout will occur, and again retransmission of that particular thing should be, means 6 will be done. Assume, for I told you like that. But what is the time required for that? How much time it will take? So this is a time consuming method. So to improve this particular concept, now assume that and 7 and 8 has been came. Until 8 comes, 7 and 8 windows fills up. If first packet not came, then only the things, means the sender will comes to know that. Until then, sender will not comes to know that. Assume when 7 will arrive itself, the receiver will send a negative acknowledgement of 6. Then within a timeout period, the sender will come to know that a 6 has not gone, and then automatically the 6th frame will be sent in a next window. So this is the advantage of negative acknowledgement, correct? No? Compare the previous example with this particular thing. Receiver sends the negative acknowledgement for 6 when frame 7 arrives. However, this is unnecessary since sender's timeout mechanism will be sufficient to catch association. Timeout mechanism is there. So again, within that, if it's sent, so that is the concept is there. But this means once timeout concept is there, why again the negative acknowledgement should be sent? Assume the negative acknowledgement will get filed somewhere, or something will happen to that, even it will come late. Anyway, timeout concept is there, it will works out. Coming to next thing, that is additional acknowledgement. what is the additional acknowledgement? Now here, receiver sends additional acknowledgement to frame 5 when frame 7 arrives. This is piggyback method. What do you mean by this? Well, very simple. Acknowledgement of 5 means last frame received is 5. So 7 and 8 arrives, 6 not arrived. So it never sends a acknowledgement for 7 and 8. The re-acknowledgement of 5 will be sent, additional acknowledgement. Then automatically their sender already fifth acknowledgement came, sir. Again, fifth acknowledgement is came means that means 6 has not reached correctly. Again, 6 retransmission will be done. But sender uses duplicate acknowledgement as a clue for a frame loss. Here, whatever this duplicate acknowledgement will be there, sender will use that, then whatever the previous frame it has been sent, it has been lost. So the previous frame will be sent back again. That means the frame 6 will be sent back again. The most popular method, sliding window protocol method, is a selective acknowledgement method. That we'll call it as a selective sliding window protocol. In a selective sliding window protocol, receiver will acknowledge exactly those frames it has received rather than the highest number frames. Now, previous two types I told you. What the highest received frame will be acknowledged, that means all frames received correctly. Until then, no acknowledgement will be sent. The next one is negative acknowledgement will be sent. Anyway, timeout concept is there. The other one is the retransmission of the last frame itself, that is the beginning frames not came correctly. So until then. Now, selective method. Now, what is this here? This is which frames received only for that acknowledgement will be sent. Will not we don't send the acknowledgement for the frame which we have not received. That is, assume the receiver will acknowledge exactly those frames it has received rather than the highest number frames. Receiver will acknowledge frames 7 and 8. Sender knows frame 6 is lost. Sender can keep the pipe full, additional complexity. What it will do, the 6th frame it will put in a next window, it will keep on sending, and whatever your last frame will become 8 plus 4 12, expect means last acceptable frame will become 12. Within that number, the 6 can be inputted and it can be sent back. So in this way, the things will be sent. 1 minute. Yeah, coming to the next thing. How to select a window size. So how a window size selected? SWS. Delay into bandwidth. Based on that, the window size will be selected. How RWS will be selected? Based on your bandwidth and distance of the receiver, the SWS will be selected. But receiver window size is very much important rather than the sender window size. Now, first, it will be 1, no buffer at a receiver for frames that arrive out of order. Then RWS is equal to SWS. The receiver can buffer the frames that the sender transmits. So it does not make any sense to keep RWS greater than SWS, usually. Why? Because the sender capacity is sending only 3 balls, means you must have a 3 balls window. Having a 4 balls, 5 balls window will not suit. Correct? No. So based on that, it will start with 1, whether it can be 1, it should start with 1, keep on increasing. So it will be there up to SWS. Now, what do you mean by this? Frame sequence number is specified in the header field. Whatever a header field will be there of a frame. So a finite size 3-bit number will be taken into the consideration. Always it starts from 0 to sequencing a number. It's necessary to wrap around. Means to identify a particular frame, it is very much important. Now, next. Coming to the next thing, that is how to distinguish between the different invariations of the same sequence number. So these things we'll discuss in a next class, and almost all we are end of this particular module, and later on we'll go with the different roles, how a frame control everything will be there, and how a Ethernet network, means LAN network, will work on which protocol, what is CSMA CD, and all we'll discuss in a next coming classes. As I told you that very clearly, whatever lab programs are given, you keep on doing that lab programs. You keep on doing that lab programs here. Listening? Hello? Hello? Yeah? You
Yes,
keep
sir.
on doing
Yes,
that.
sir.
Yes,
Yes,
sir.
sir.
You go with the textbook, soft copy is, sorry, soft copy is there with you. You can go with that particular thing and you can read the contents. As this video, I will put in a YouTube channel of a department, so you can go through again, you can read again. The variables are very much important. The explanation of that variables in a sliding window protocol is rather than very much important. Okay, thank you very much for attending. Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you.